Hey y'all, welcome back to my channel Land Before Time, with your host, Littlefoot. If you didn't get that reference, you probably grew up on Dinosaur Train. Either way, welcome aboard. Today we're going to be covering Valid Palindrome. This is going to be on the easier side. In order for us to tackle the harder two-pointer problems, we have to start somewhere. It's not like when the stars align and the moon is in waxing crescent, only through the power of the moon and the stars will you gain the strength to squat 300 pounds. No, you don't wait for the stars to align, you just start it. And you start with something like body weight squats, and you add 10 pounds at a time. So similarly, we got to build that Leetcode muscle. Let's get started. A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome, or false otherwise. Okay, so the goal of the problem is to check whether the string is a palindrome. Some questions I have are, can S be the empty string? Based off of the Leetcode constraints, no. Will the letters in S be all lowercase? No, S can contain any ASCII characters. Since that is true, does that mean uppercase A and lowercase a are considered different? No. What happens when there are non-alphanumeric characters such as commas, periods, colons, etc.? In that case, after removing them from the input, determine if the string is a palindrome or not. Okay, cool. Now that I know what I'm trying to solve for, let's go ahead and take a look at some examples. We know Taco Cat, spelled backwards, the game? I haven't played this game. Instead, I've played its non-palindromic counterpart, Taco Cat Goat Cheese Pizza, which I highly recommend for a chaotic evening and maybe some emotional damage. Similar to the Leetcode grind. Wait, this is not a board game review channel? Back to brainstorming. We know for this to be a valid palindrome, the word must be spelled the same bidirectionally. So in the case, if we remove this space over here, we know that Taco Cat is equal to Taco Cat. The first thing that comes to my mind is we create a new string that only contains alphanumeric values. So for example, we'll take Taco Cat, we'll go ahead and remove all of the non-alphanumeric characters. So in this case, there's only one space. So we go ahead and remove that, and this is a new string. And we have Taco Cat here. Then we go ahead and take this new string, and we start at the ends of the string, starting at I and J. And next what we're going to do is we are going to move the pointers closer and closer in until I and J have passed. So we'll move J here, A here, move J here, and then I again, and then we'll move J one more time, and same thing with I. The next iteration, I will have crossed J, so we know to stop here. And in this example, we can see that the pointers are always equal to each other. T is always equal to T, A is always equal to A, and so on and so forth. If we had another example, such as race a car, we would realize that everything would be the same until we hit the C's, and then we have E and A as a mismatch, and therefore this would not be a valid palindrome. If we take a look at the runtime of the solution, we will get O of n, because we have to go through all the characters in the string. And the space will also be O of n, because we are filtering the existing string and creating a new one. So let's take another 30 seconds. Is there anything that we can improve on, runtime or space-time wise, and see if we can come up with a better solution? In this particular case, the runtime cannot be improved because we have to go through every character in the string. However, space can potentially be improved since we are creating a new string every single time. The output result is a Boolean. What if we had something like, what we want to do is we're going to start with the same mechanism of starting at the ends I and j. In this case, when we come and approach the C for the j and this dash for the I, we want to take the I and keep moving it forward until we see the first alphanumeric character. Now, the space will be constant time. This is a better solution than our first solution. Now let's take 30 seconds to gather our thoughts and create a blueprint. Iterate over the characters in the string until I is greater than j. Move I until it's an alphanumeric character. Move j until it's an alphanumeric character. If character I doesn't equal character j, return false. Otherwise, at the very end, return true. It's time to put those rockstar coding skills to use. There we have it, valid palindromes. If you found this video helpful, then give it a like, comment, share, and subscribe. Happy Leetcoding, and see you in the next one.